All right, here's the experiment. This is your one project for the semester, and we're going to do some real science, which is really exciting. So what you need to pick up from the store is iodine. It costs about $2, and you can get it just at the grocery store. So let's take a look at what this is. If I open it up, you can kind of see the color there. So make some observations. Go ahead and let's read the back. So it says iodine 2%. It's an antiseptic. It's used to in first aid to prevent skin infections. And so I wonder how it does that. What do you think it helps prevent from getting into your wounds? It says here, caution poison. So do not ingest this. Do not eat the iodine. That is a bad thing to do. But we are in the kitchen, so we're going to test a couple different macromolecules for the presence of carbohydrates. And so carbohydrates are things like sugars. So you might find carbohydrates in this mango. You might also find carbohydrates, let me go get it, in this potato. Sugar, another name for carbohydrates. What do you think about oats and rice? Okay, so all of these things have a big long chain of monomers that come together to make a polymer. And we are testing with iodine the presence of that molecule. Now this is different from things that have, say, fats in them, like lipids. Like, for example, this avocado has a lot of fat in it. Really good fats too. Avocados are amazing. Here, let's go see if we can find some other. This is my cabinet. What else do we have down here? We have peanut butter. We can read the back. And it says total fat has 16 grams of fat. Can you see this? And 7 grams of carbs, 8 grams of protein. Peanut butter is pretty awesome. Let's see here. What about coconut oil? What do you think coconut oil has? Coconut oil is mostly fat, so it's mostly lipids. Let's see here. No carbohydrates, no proteins, no sodium. That's pure fat right there. Pure oil. Good stuff. And then what about something like the sweet potato? Yep, that has carbohydrates in it too. So that is what we are testing for today. We're going to set up a controlled experiment. So I'm going to show you how this goes so that is a little bit easier for you to do this project. So switch the camera around. The first part is just practicing with iodine. Like we just observed, it's a yellowish brown solution. When iodine reacts with starch, a color change will be observed. The iodine will form a starch-iodine complex. This starch-iodine complex is dark blue-black in color. And remember, that's the light that's reflected off to us, and that's what we see. Everything else gets absorbed. So when it's yellowish-brown, it's absorbing all the other colors except for yellow. And when it's black and blue, it's absorbing all the other colors and reflecting back the blue color. Iodine is often used to test food for the presence of starch. If the food contains a starch, a color change will be seen from yellowish-brown to blue-black. So we're gonna, at the end, for the second part, we're gonna write a research question. But for this lab, we're just gonna set up our variables and a positive and negative control. So our independent variable, what are we changing here? We wanna test different types of carbohydrates and how they react with iodine. The dependent, so our independent variable then is the type of carbohydrate. The dependent is what we're going to go out and measure. So we're looking for that color change. So the dependent variable is the color change. The control is what we will, 1 or 2 sentences to state what aspects of the procedure that will be consistent in each trial in this investigation. So if we put, let's say, 1 drop on the potato, we want to also put 1 drop on the rice. Okay, we just learned that we shouldn't ingest iodine. We should wear eye protection. So maybe if you have glasses, you could wear those. If you get iodine on your skin, you can just wash it off with warm soapy water, and it might stain your skin yellow. You can wear clothes, maybe an apron. Do not heat up the iodine. Throw away food tested with iodine in the trash. Do use hot soapy water or a dishwasher to wash dishes used during the test. Iodine may go down the sink with warm water. Good to know. All right, materials. So you're going to take some tap water, a baking potato, table sugar, lemon, unsalted saltine cracker, white rice, any pasta, and 1 sample of your choice. So here, if you don't want to go to the store and buy any of these, I actually didn't get saltine crackers. You don't have to. So just test whatever's in your house. Test a bunch of them. Okay, so you want wax paper and a toothpick, and that'll help. And then your bottle of iodine. Make sure you have an adult there. Clean up all surfaces, gather materials. Okay, set up other controls. So our negative and control will let us see how iodine reacts when there is no starch present. So here we're going to place 2.5 milliliters or a half a teaspoon of water on wax paper. Record the color of the water on your data table. Let's go ahead and do that. Okay, so here we go. There it is. There's our water. And I'm going to drop my iodine on it. Oh, I really should have an eyedropper. That would be way more helpful. I think we can make this work though, at least for the negative control here. So you can see and make an observation about that. What color is it? How does it react with just water? Okay, so follow specifically the directions in here for the negative control. You want to do one that's without any iodine, one with iodine, 3 drops, and we're going to use the same for each trial. Why is that important? And then gently stir with a toothpick, and the last one is wait 30 seconds, and then take a picture of the 2 tablespoons and record the final color in the data table. So you can make a copy of this. You want to just make a copy, so you can make a copy right there, and then it'll be yours. You don't need to request access. Okay, so then you can record the color. Is it yellow or purple? And then finally you get to conclude, is starch present, yes or no? And do 3 different trials. Why is that important? You want to make sure that every single time you do it, you get the same result, and then you can come to a more supported conclusion. Okay, so moving on to the positive control. We're now going to take our potato, which we know has starch in it, and we're going to blend the potato. We're going to blend it up. So take your potato, cut it into a couple different pieces, and then put it in your blender with some water. Oops, okay. So when you do that, then if you don't have a blender, you can also just try to mash it up. And let's see what would happen if you were not to blend it. So just taking my potato, cutting it, and putting the iodine on. And you can see just pretty well what's happening. It's actually pretty neat. You can see when it initially hits, it's that lighter color, and then as it reacts with the starch, it starts to change. Ooh, this is like potato art. That's pretty fun. So maybe make a little design and show me. So really what you want to do is cut this up into cubes and then put it in your blender. And you're going to do that for every single one of your food items. So make sure you keep that consistent, keep that as a control. Your same method for every single food item. And the specifics there are in this document. So let's see. 2.5 milliliters or half a teaspoon of potato solution onto wax paper as when you drop the iodine on. And the iodine, you're going to place 3 drops or a quarter teaspoon if you don't have a dropper. And of course, you want to add the same amount. Okay. Now, setting up the experiment, basically the same, like we just said, a 1/4 inch of each food item, put it in the blender, take out with 1/3 cup of tap water. Now, what might be different between my house and your house? For example, the tap water here in Moab has lots of minerals in it, which you will find out if you do the potash participation challenge. There's lots of salt. This Moab used to be a salt dome that collapsed, so there's lots of salts that are seeping through the rocks, and that ends up a little bit in our water. So that might be something that's different between my house and your house. But if we're using the same tap water throughout this experiment, that should be good. So you're going to test it all out, and then you're going to end up with a 9-row by 2 tablespoons, with 2 tablespoons per row. So that is each one of your food solutions in 3 different trials. So 1, 2, 3, 4, 5, 6 for potato solution, table sugar, lemon, saltine cracker, white cooked rice, cooked white rice, and then your choice of cooked pasta, and then your choice of anything else. 7, 8, 9. Okay, so there's your 9 by 9, and it looks something like this. And that is what you're going to make observations from. Fill in this data table, and then come to a conclusion. So clearly state which foods do and do not contain starch, and support your conclusion. And here's what we can conclude here from our initial experiment. A dark purple color was not seen when iodine was added to the water. Therefore, it can be concluded that the water does not contain starch. And here's what we might write for the potato. The potato solution was not dark purple before the iodine was added. A dark purple color was seen when iodine was added to the potato solution. Therefore, it can be concluded that the potato solution contained starch. So you'd write the same thing for the rest of what you find, and then discuss any errors. For example, I just started this and I didn't have a dropper, and I also figured out I don't have a tablespoon, because this is a new kitchen. So hopefully you have a tablespoon or teaspoon measure. And then we just talked about maybe tap water being different, maybe you had blender errors. What should you probably do between trials with your blender? Yes, that's right. You want to wash it out between each trial. All right, and then further research. State 1 or 2 possible additional research questions that could be explored based on your findings in the investigation. So that is, that's all. That's all it is. That's part A. That's me and this spud saying, hey, get it done, do it, have fun getting wet, doing some wet science. That's what they call it, wet research. At your lab bench, which is your kitchen table. Let me know if you have any questions, as always.